Alright, should be a new video and such. So we'll do the live chat and we'll pop out this and that and do these little things that I have to do. And then we should be okay. Or something like that to make a video. So the chat didn't show up. So I'm going to find that. There it is. Okay. Yeah, there it is. Yeah, okay. So we can see if anything has any urgent thing to say, like the sound isn't working or some other kind of crap. But everything looks like it's working, which is good. Alright, the other good news is, I mean, it's a giant leap for mankind kind of thing, actually. It's this is really quite encouraging. Now, the discouraging part is the Johnny Walker funny because he has his head up his ass. Anyway, or his, a little wiener. Anyway, he posts all these comments, in the thread, and, arguing with me in somebody else's video comment section, which is really tacky, and he can't figure that out. Anyway, so the physics Michael guy responded, which, I was getting kind of discouraged, admittedly, that, she's just not going to play along. So anyway, he states, let's see if you can see any of that. Well, you can see most of that, which is enough. I'm putting together a video with experiments that will specifically test this. So now what we're going to get probably is braking distance again, But yes, thinking about it, what other experiments are there? Okay, besides braking distance, what else do they have as an experiment that demonstrates the existence of anything called kinetic energy? So they don't have it showing us 4 times the fuel for twice the velocity. That's the big one. I mean, that's huge, gigantic. I mean, that's decisive. I mean, if you can show it taking 4 times the fuel to go twice as fast, big one. But they won't do that. Anyway, and some other comments that Draft Science was making about whether the work and energy equation. So obviously I'd say on its face, I mean, we'll talk about the work equation, but I mean, it's just on its face really horrible. I mean, especially in the context of Galileo's 500 years ago. And he sort of demonstrated to you quite obviously that it's about how long something's in the gravity. And you can use a ramp to lengthen the amount of time something's in gravity. But the catch is, okay, the whole time it's falling, it's being pushed back. So the friction is absorbing all of the extra energy that you would have gained from the extra time in the gravity. So, but it's all just, anyway. Energy equations commonly used are accurate. Okay. Making whether, yes, so I'm claiming they're not accurate. And, they're really, frankly, ridiculous considering the lack of evidence. So considering the lack of evidence that, a 100-mile-an-hour crash crushes a car 4 times as much as a 50-mile-an-hour crash. So I could go back to the Mythbusters video and, point out how they didn't see any of that. And then when they made a clay model of 50 miles an hour and 100 miles an hour, they didn't see any 4 times. Anyway, hopefully bringing quality data to the table. Okay, so that's all we're looking for is something called quality data. Okay, so I've pointed out you can't really go to MIT for it because you'll see that they, commit shenanigans in forcing the experiment to match the theory. So that's the big liability. Has the experiment been done with an agenda to match the theory? Are they trying to prove a theory or are they trying to find the truth? Big difference. Data at the table will clarify some of these misunderstandings. So again, you can say I have the misunderstandings. It's okay, but I'm just saying it's a direct accusation that I'm not misunderstanding anything. You are, okay? And you're doing it in this atmosphere where you really don't have anything called evidence. So you're making a claim, okay, kind of like people with UFO evidence, and it's all kind of shady evidence. It's all weak. Okay, you got, you're going to go all the way back to the 1700s and talk about dropping round things into clay? And tell me, because that experiment shows a 4 to 1 relationship instead of a 2 to 1 relationship, that somehow that proves the case. I mean, because yes, I can show how you're misunderstanding the difference between pointy things and flat things regarding penetration depth. But anyway, while keeping the discourse positive, yes, it all should be positive. Clearly, I don't have any personal grudges against you now. There's a lot of people who have personal grudges against me because I say things that, about philosophical things and political things that they don't like, and so they have to try to destroy my credibility at every instant. And so some of that is going to spill over just as a necessary, I have to spend some time defending myself against these lazy accusations that I have not done my research, or that I misunderstand. Anyway, it should be up by the end of next week. So I have to wait for it, which sucks. I thought that said this week, but it's just next week. Oh, crap. All right. So anyway, that's positive anyway. I was thinking of replying with something, but I'm saying, well, I'll just wait on my reply. Thanking him for continuing the participation, and hopefully he can produce some kind of evidence that isn't tainted or irrelevant or something else, easily demonstrated to not show what you're claiming to be an absolute truth. So I still say that this conversation needs a survey, of questions, just to find out who stands where. I mean, who's really defending free energy and who's just defending some sort of mathematical tool, okay, that doesn't have anything to do with reality for whatever reason, or some sort of other thing, because, there are underlying principles here that are a foundation, and all of those, in some respect or another, are being challenged by which side, you fall on. And so that's worth talking about, I suppose. So I'll do some talking about that. I guess, some of the key points that I've been over and over, and I'll just see which ones I remember, and then we can go over what experiments actually exist. And so I'll see if I can think up any more experiments than what I've already pointed out, which is breaking distance, which doesn't really work, frankly. When you actually research it, it ends up being a 3-to-1 relationship, not a 4-to-1 relationship, so it doesn't even match. But besides that, you can understand, because of what Galileo informed us about gravity, that gravity's creating the friction. And because gravity's creating the friction, it's a time-dependent force, and the fact is that you'll roll 4 times as far, but you only did it in twice the time. So you were only getting pushed into the surface twice as long by the gravity. So you only overcame 2 units of gravity. You didn't overcome 4 units of gravity. So yes, you traveled 4 units of distance, no doubt about it. But those 4 units weren't under the same pressure. So the 1 unit was the same as 3 units of time. So in 1 unit of time, you traveled 3 units of distance. And over that large distance, you only had the weight of 1 unit of gravity. So obviously you were distributing your momentum to the ground, in very different rates depending on your speed. So at the high speed, you're distributing less per foot to the ground, and at lower speeds, you're distributing more per foot to the ground. And that's why there's that. There's probably a word for it. That anomaly, that anomaly is explainable. It's because it's the same explanation you have for the fact that twice the velocity gets you 4 times higher into gravity, because twice the velocity means you're only going to be in the gravity twice as long, not 4 times as long, only twice as long. It's only 2 units of gravity you're overcoming, and the fact is you get 4 units of distance. But they're obviously, again, not the same units of distance. In the first part of your travel, you'll go 3/4 of the distance, and you'll have half the velocity after going 3/4 of the distance, and you lose the other half in the one tiny quarter. 1/4 uses up half your energy. Just the way it works. And it's, the inverse going down. you gain in the first quarter a full 9.8, and it takes you 3 units to get the 9.8 as you increase your velocity. So these are all things we've talked about. I think it's an important context, and obviously very few of the critics think it's important. So anyway, the defenders of the conventional theory. All right. So, and again, I can make these arguments over and over. Do you really think it's a rational work equation if the work equation doesn't account for how long it takes you to lift something, for example? So if I lift a barbell and I do it really slowly, you think it's the same amount of work that if I lift it quickly? When we know that the only thing I'm lifting really is against gravity. I'm not lifting a weight. I'm lifting the weight created by gravity pushing the object with a velocity. And that's what I'm fighting against. And that that force reigns at a rate, per unit of time. So the longer I take to lift it, the more of that gravitational force I have to overcome. And the shorter the amount of time I can do the lifting over, the less I will pay for it. The less gravity I will have to overcome. But anyway, so it doesn't make any sense. I could be holding a 10-pound weight in front of you, and I just hold it, and I say I'm not doing any work. I mean, on its face, does that sound like physics getting the right answer? All right, and then we can do all these other examples. Okay, so one thing to think about is, number one would be, yes, what we need is the 4-to-1 fuel relationship. Okay, the 4-to-1 fuel. All right, because that's the real prove it. Okay, you want to prove it, show that it takes 4 times the fuel to go twice as fast. I guess that's how I should put it. 4 times the fuel for twice the velocity. No, it's probably some shorthand I could write that in that would be better than this. So we'll just call it, whatever. That's what it is. And then you got the conservation laws, right? So conservation. Do you believe momentum has to be conserved? So they say it. They're all quite confident. Lewin says, you can fudge kinetic energy, but nature can't finagle, momentum. So it's a real thing, can't be finagled, and not that hard to figure out that the momentum is the real thing and the kinetic energy is sort of a fake thing, because you really have to recognize you have to conserve it. All right, and then what do we have for experiments that demonstrate which one is real based on which one is actually conserved? And so again, we don't really have any experiments. Okay, I can't identify an experiment that really decisively shows kinetic energy at work. Now, they do have this weird, I guess we don't need any of this crap. They do have the weird, 2/3 the momentum goes in a direction experiment, right? And so I have a 1 mass hits a 2 mass, and the momentum in this object somehow increases. So if it has 100 in momentum, that is, if it has a mass and a velocity, okay, and here it's going to have twice the mass, okay, and somehow it's going to have 3/4 of the velocity still. So it's going to have 133, okay, because we're going to send this back with 33. Okay, and so this is when we get into this scalar crap that I had to block people about yesterday, because there's no origin for it. You can't show me where at some point in physics history all of a sudden they declared, momentum a vector and kinetic energy a scalar. It's a gimmick. They all kind of accept it over time. So I don't know if you could even find the first person that said those words. That somehow these are different forms of energy, and that somehow one of them has a direction, and somehow, even though they're both made out of MV, so they're made out of exactly the same thing. You're just doing this. You're putting a silly little half over here. Who cares? How can that have anything to do with anything important? and a square on the velocity. Those things can't change the properties of the mass and the velocity. So whatever properties the velocity had, it's the same properties whether you put a half or a square here. You don't all of a sudden make an arrow going this way into an arrow going that way. I mean, it's, it's ridiculous to say one of them is subtractable and one of them isn't. That somehow, you could subtract energy from something moving in a direction in terms of its momentum. You could subtract it by sending something that way, but it doesn't work with scalars somehow. Somehow the scalar energy you can't subtract. Because it doesn't have any direction somehow, when clearly it has to have a direction. It has a direction in the experiment. It's going a definite direction. So anyway, this idea, okay, so this is their mathematics. Their mathematics says this is rational, that I can increase the momentum. So I've explained that, well, that's got to be problematic. If I'm making free momentum, I think you should realize, wow, you got a real circumstance, but you're violating this conservation thing, right? You're saying forget conservation. Because really, this idea that because something went back this way, you undid it is kind of ridiculous. So the idea is 100 goes in and you get 166 total out, right? You have stuff moving in this direction, affecting things in the universe. You have things coming back this way, affecting things in the universe. It's all real momentum. It's not fake momentum. And I could illustrate it with, something rather simple. I mean, I just changed the experiment a little bit. And I just put two objects here, and I squish this one through. All right, so say I have two bowling balls, and I put them so close to each other, I'm going to hit both of them with this ball. Do you really think it's possible? Let's just say I even put a wedge here to guarantee that as much as possible of the energy goes through. So I crash this into a very light wedge, and the wedge pushes the two balls. Do you really think it's possible I could have 133 over here, and I could have 33 go this way? No, that's not going to happen, right? It's going to be split 50-50. So it's going to be 80 and 80 by your theory, because I got 166. So I'm going to end up with 83 going this way and 83 going this way, right? And I only put 100 in here. So with 100 momentums, MVs, I'm going to create 83 going that way and 83 going that way, because these will subtract, and I'll end up with 0, right? So 0 isn't right answer either. Somehow I still have to end up with 83 with some amount going this way, or I'm converting it. But I'm just saying, it doesn't make any sense. I can't make free momentum. And so then I've explained the experiment over and over again, that I could just simply take and make a 1 ounce, then a 2 ounce, then a 4 ounce, then an 8 ounce, and then a 1 pound. I probably don't even have to go that high. But anyway, and I just collide them into each other, and I keep increasing. So I go to 133, from 100 to 133, and then to 170 whatever, and 5 we'll say, and then to 230 something or other, and then to 350. Okay, so yeah, I just keep increasing the amount of momentum, and then I just put it into a lever and just repeat the process, right? So I just put it into a lever, okay, that is a reliable conversion device. One distance here, two distances over here, small object starts here, and I'll just have the 350 momentums, okay, because I did conserve the energy with the lever. Do you believe that energy is conserved by levers? Is that going to be a viable question now? I mean, what objects don't you think conserve momentum? But I mean, it'd have to fail kind of catastrophically not to be able to get this to go faster than this 100 that went in. So 100 goes in, I'm up to 300 times, 3 times as much energy hitting the lever. And what's your expectation, that this is going to leave with 100 or less? Yeah, no, I think it has to leave with, even if it has some losses, it's got to have at least 200, which is twice what I started with, and then I got 200 doing the same thing. I just keep increasing the weights, doubling the weights, doubling the weights, and I just do the same thing on this side, and I just keep increasing and increasing the energy of the system. by your free energy logic of this silly formula that somehow can create free momentum when I bang a light object into a heavy object. Which still doesn't make it, you just sit there and stare at it and say, come on, you really believe that happens? All right. The energy going this way is just inconsequential. Frankly, it would help this device because it would actually push the lever back, so it would reset it for pushing forward again. So every time everything went through it, the back pressure of 33 would just guarantee that the lever works even better. And it's even more efficient at pushing the objects. So this particular experiment. So again, we'll just have to wait and see if he has some new experiment to show us, because we've all been looking. We'd all like to see this perfect kinetic energy experiment, and it doesn't exist. Well, not even perfect, right? A really credible experiment. Really demonstrating 4 times the fuel to go twice as fast. Demonstrating that springs don't conserve momentum. That they're really kinetic energy conservation devices. Something, that I really can, I can't convert a 10-ton train, okay, going 5 miles an hour into a 5-ton train going 10 miles an hour. So in this example, right, it's logical. Okay, they got the same momentum. If I did it on a spaceship, okay, and I throw the 5 pounds, let's just say, out this side of the spaceship at 10, okay, or I throw the 10 going 5 out this side, their theory says I have, if I throw the 5 going 10, I'm going to be turned more than throwing the 10 going 5. Now, NASA knows it's the same difference because NASA knows it's just about mass and velocity, and there's no squared fake energy that's going to make any difference. So thrust is decidedly made out of masses moving velocities. And NASA knows that I could have one atom moving 1,000 miles an hour, or I can have 1,000 atoms moving 1 mile an hour. And those two things are going to turn the ship the same amount too. Do you really believe otherwise? Do you really believe that it matters that you're using lighter things and throwing them faster somehow makes more energy, turning energy, than heavy things moving proportionally slower? So to me, it's a pretty decisive argument, the fact that NASA doesn't. It says things like, we use Newton's mechanics. Okay, so it sort of just says, and they're saying that because they don't use Einstein, but they're also saying it because they don't use Leibniz. They don't use living force. Living force doesn't land you on the moon. And I think they're kind of saying it. So anyway, Toady, who unfortunately kind of fell out of the game because of the contentiousness that exists between the existing players in the conversation, frankly rudeness, of the draft science detractors, their grotesque excesses in poor rhetoric. Anyway, kind of fell out of this, but he was going to do, which is kind of the same experiment as you can logically sort of understand that you can do it with, this simple pendulum. So, this is not a very complicated experiment. It really should be doable. So you have a 2 mass and a 1 mass, and you make sure they collide right on their centers of their masses. And you should be able to duplicate this free momentum scenario where you crash the 1 into the 2, and the 2 ends up going 3/4 of the velocity, which will sort of be related to distance. It's distance up that you're really calculating, so you have to be a little bit careful and not be fooled by lateral distance versus up distance. You're doing more up work the further out you go, so you get a little bit of this for free because you're not going up much. As you go this way, the up arrow gets big, the sideways arrow gets small. Here the sideways arrow is big, and the up arrow is very small. But regardless, understanding that you're really measuring how high the thing goes, do you really think, okay, that this is going to go something more than the quarter of the distance it's possible for it to go, really, realistically? It's basically got to spread the energy over twice the mass, so it has to go half the velocity, and half the velocity is in fact 1 unit of gravitational distance. And that's all you're going to get. Anyway, so this was going to be the experiment. So just again, another way of doing it. I did it with a ballistic pendulum. I didn't get these, I didn't get the free momentum in my experiments, but they were imperfect. Like I said, the pieces of steel I used long pieces of steel, and I should have used, I suppose, something more confined, because yes, they did tend to turn when they collided, which messed up the frame rate counting. Anyway, so it's a pretty simple experiment. I put 100 in, whatever. I established some amount in. I should get 133 by their math going this way, and then 33 going this way. And we're to believe that that's not extra energy in the universe. When, again, if it was an explosion, you'd count this as energy and you'd count this as energy. So if I create an explosion and I moved a 1 mass 33 and I moved the 2 mass 133, you'd say, well, that all counts. So if this was an explosion, you'd count this and this. You wouldn't subtract this from that and say there's only 100 joules or 100 momentums of energy in the explosion. No, you'd count the stuff going this way and you'd count the stuff going that way. So the formula breaks down in fundamental ways that don't make any sense, because if I'm measuring the energy of an explosion, all of a sudden momentum isn't subtracting. But if I'm doing some other experiment, all of a sudden momentum one way subtracts from the momentum the other way. That somehow it undoes it, and it never happened. It wasn't real. So obviously I would argue that if you believe in the conservation law, there's no way you can say you could start with 100 and end up with momentum in the same direction that your 100 went in with. How can you have more momentum in the same direction? You're going to change 100 into 133 in the same direction, and you're going to pretend that because something went the other way, this 133 isn't happening. It isn't really the same as this. I mean, I've said it. How can you believe it's possible to have an experiment? Well, here's your experiment, your little black box experiment. You put in 100 and you get out 133. I mean, how could you believe that is possible in the universe? I mean, it doesn't make any sense at all. All right, take a little break. See if any commenters are commenting. Maybe we'll leave it at that, because I've been over all this stuff so many times, and really, until you have an actual experiment to critique, to analyze, you don't have much. And the point is that I think it's obvious. I mean, NASA doesn't use it. Professional bowlers certainly don't use it. Okay, there's no professional bowler, I think, in the history of bowling who ever used an 8-pound ball or a 6-pound ball or a 4-pound ball to somehow, I don't think they legally can, but they could probably use 8. No one's done it. So clearly it doesn't work to their advantage. So even though the lighter ball moving faster produces much more energy, twice as much energy, twice as much presumable ability to make pins move, nobody's using it. Nobody capitalizes on it. Nobody even moves to a 14-pound ball or a 12-pound ball to take some advantage, to gain some of this advantage, to gain a 0.4 advantage or a 0.3 advantage. So nobody has ever been capable of exploiting this, this energy circumstance that allows light things to produce what seems like more energy than heavy things. And it's all based on them claiming that I can't throw the lighter ball twice as fast because I need 4 times the energy or something. Like somehow there is some limiting factor that I can't throw a twice as light thing twice as far. When I think if you let shot putters throw something that's twice as light, I bet you they can throw it twice as far. So I bet all the other examples of where somebody is actually throwing something that yes they can, and the limitation would be say in baseballs, because the lighter you make the ball, the more the air resistance is going to degrade, and it's going to be harder to get the velocity out of it. Harder to put enough energy into it. Because the speed gets really, really fast. Yeah, the maximum speed. So what else is there? But yeah, they don't have any evidence, and they just keep defending a theory, and it's just a theory. It has a terrible history, so I went through that too. So you're breaking conservation laws, frankly. Meaningful ones, conservation of momentum. You're basically endorsing the idea that levers don't conserve momentum, that hydraulics don't conserve momentum, that frankly nothing does. Springs don't conserve momentum, because if they do conserve momentum, the experimental result becomes ludicrous. That is, I compress the spring the same amount and release the energy, and somehow I don't get the same momentum out. I put a lighter thing on the spring, somehow it doesn't work, and I only get 1.4 the velocity instead of twice the velocity. And the same with the lever. That even though I can get the lever to oscillate with this object twice the distance, half the mass, moving twice the velocity, it'll oscillate perfectly, but somehow if I want to launch these objects, it won't work anymore. So it'll oscillate with the 2-to-1 relationship, but I could only release energy at a 1.4-to-1 relationship. But somehow the kinetic energy will be conserved once it starts flying. But as long as it's just oscillating, its momentum's in control, and then as soon as the oscillation stops, all of a sudden kinetic energy kicks in and stops things from going twice as fast. Again, a tug of war between a 10-ton train going 5 miles an hour and a 5-ton train going 10 miles an hour. That's the kind of tug of war we should have seen. Just inverse relationships, mass to velocity ratios. The bullet and the recoil of the gun. We should see that tug of war. And you should show me the bullet winning by 1,000 times more energy, so that it decisively pulls the gun in its direction. Decisively. I mean, 1,000 times more energy. Okay, it doesn't move the tug of war or little tape, just do a little bit. No, it dramatically moves it because it has so much more energy. Now, we haven't seen any of those experiments, and I don't think Michael's going to show us any of that. I think he's just going to dig up the same crap, okay, of braking distance, and they don't really have anything else, right? There's braking distance, and then there's the experiment, in the 1700s with the clay that nobody in the modern era has repeated except for the Brozo, and that is theoretically broken as it's a bad thought experiment, in the sense that if you understood what you were really doing, which is dropping round objects, and then if you dropped non-dimensional shaped objects, flat things, into the clay, you won't get these results. So it's just a phenomenon of the fact that arrows that have good points on them penetrate deeper than arrows with crappy points on them. And it can be defeated with an argument that simple, that you really should understand that the same pressure will push a sharper needle deeper into your flesh. So nothing miraculous there. It's not doing more work. It's creating a mechanism that facilitates doing the work, makes it less noisy, less waste. a more perfect penetration with less waste involved. Yeah. All right. Let's see if there's anything in the comments section. We'll see if there's anybody got anything reasonable to say. And again, the chatters could put actual comments on videos, if they need to link to something or any of that kind of crap, and they never do it. Instead, they usually just talk trash, but we'll see. All right, life and reason. Could you do a re-introductory class for physics in the future about your point? I feel like a lot of people would benefit from that about your ideas. Thank you. Yes, well, I have a channel called draftphysics.com, and frankly, it's all there. Okay, I mean, especially the newer videos, it's a more concise and more precise description of the circumstance. And so, the kinetic energy's covered, the two slits covered. There's pretty damn good videos there. So watch those videos. Anyway, I mean, it'd be great. Eventually I have to compile all this into some sort of lesson plan. But I don't have staff and all of that crap, and so this isn't, takes a little bit of time and work, and it's all, conventional physicists don't have to make all these arguments in defense of, so they don't have to counter the 4,000 objections because nobody objects. Nobody points out, well, that doesn't work. That doesn't produce the right pattern. Why are you saying it fits perfectly when it doesn't fit well at all? The single slit water wave doesn't look anything like the single slit light photon pattern. Their theory says that both these things have the same effect on the momentum of the ship. Okay, well, explain how that's true. So that's all I want you to do. So I did something inside my spaceship, all right, and you're saying I create 2,000 joules going one way, and I only have 2 joules going the other way. And you're saying that they think, okay, even though it's 2,000 joules I pushed out of my spaceship, that somehow I don't have the opposite reaction of 2,000 joules. You get me? I mean, you can't sit there and have a, you can't say it's not real energy, because then I can just turn it into, okay, let's draw that one. What the hell? We need to temporarily get rid of this. And I can erase. So let's expand the experiment one level deeper. Okay, and that should illustrate it. So I'm going to do this experiment in my spaceship. Okay. All right. So it's a really crappy 1942 spaceship, but anyway. Camera's not quite right either. All right, I'm gonna turn this. I got a new chair out of the garbage. It's just not quite what it needs to be. It's a little too big. Anyway, so I have to make room for it. All right, so I can do 2 experiments here. I'm going to take a zip gun, okay, with 2 bullets in it going that way and a bullet going that way, but only one bullet has charge in it. Okay. So only one bullet, the same explosion is going to take place in both my experiments. And what I'm basically doing is I'm opening a little hole on this side, and I'll let that side fly out, and I'll let this side hit my spaceship. Okay, equal and opposite. All right, 2,000 joules hit my spaceship. That's what your theory says. Their theory says 2,000 joules hit my spaceship. Well, let's say 1,000. Because, right, we're splitting the bullet into, it's still 2,000, because you're eliminating the recoil of the gun and converting it into the speed of a bullet. So it's 2,000 joules. All right, hits my spaceship. And then if I put the gun inside the gun, okay, do the same thing, right? So I just put a gun inside of a gun. All right. All right, they're sealed. There's no openings for the gun, so they're going to absorb all the energy. And I put the same explosion of a bullet inside. The fact is now I only got 2 joules hitting this surface. So there's only 2 joules hitting the surface, and 2 joules fly out the window. So I got 2,000 joules go out here in the speeding bullet, and only 2 joules go out here, right? And the same thing hitting my wall here, okay? And you're telling me they say, okay, that the spaceship doesn't turn. They say, okay, that it doesn't turn differently in those 2 circumstances, and because that would be the 2 circumstances I'm just saying invert, right? So instead of it going out this side, just have this one go out this side, all right? And so this one crashes into the wall, all right? So I did these 2 acts almost simultaneously. Almost simultaneously, I shot a bullet out this way, and almost simultaneously, I shot one of these gun barrels out the other side. You're saying their theory says. Well, I'm saying how can their theory says, because I have 2,000 joules hitting this surface, and I only have 2 joules hitting this surface. How can this ship move the same amount? So saying it, they're saying, okay, show me them saying it. That's why we need a survey of you people. You know, do you believe in conservation of momentum? Do you think, okay, 2 joules thrown at a spaceship is the same as throwing 2,000 joules? So if I throw 2,000 joules in the form of 1,000 atoms, you know, I can have 1,000 atoms moving 1 mile an hour, or 1 atom moving 1,000 miles an hour. And if I throw those 2 things at a spaceship, you're saying they say the same thing happens, when they're clearly gigantically different. This one has 1,000 times more energy. How can you 1,000 times more joules of energy? How the hell can it have the same effect? If it was wattage, you wouldn't be able to say, well, 1,000 watts, 1 watt, same thing, same effect. Come on, ridiculous. Sorry, it's sort of ridiculous. It just is. I mean, how can you argue this? Okay, 1 minute the joules are real energy, real watts. The next minute they're make-believe, and we'll just revert back to momentum being the controlling function. You can't be credible, in my opinion, and play both sides of the street like that. You have to commit to one of these things and say one of them is real and one of them is a fable. They both can't be meaningful definitions of anything. And frankly, yeah, they're obviously not. Yeah, one of them is just that, a fable. What am I looking for? That. Okay. All right. Let's see. Their theory says that both those things have the same effect on the momentum of the ship. So again, show me them saying that, because it doesn't make any sense. So go ahead and say it. Say 2,000 joules is the same as 2 joules, and then I'll point out how. See how silly your theory is? You're saying 2,000 watts does the same work as 2 watts. Oh, okay. Well, that doesn't make any sense. Sorry, you're silly. All right, I'm late. Well, I don't care. I find it creepy that Mindless Marbles subscribes to viewers of graph science. I don't know what even that means, but why would that be creepy? He obviously has a little of an obsession. Okay, yeah. He finds me like Svengali or something. You know, I just somehow hypnotize him into being totally devoted to whatever, being obsessed with whatever it is, every movement of the monster. All right, the sharper needle exerts more pressure on the flesh. Well, again, you can say this nonsense, okay, but it's only in a context, so it doesn't. It can't exert more pressure total. It can only exert more pressure per square atom. Okay, so, and of course, that's exactly the point. That's exactly the point I'm making, is that the shape of an object matters because it changes like a lever. It converts the momentum, okay, into a different kind of intensity, hitting fewer atoms with more pressure or weight. All right, pressure is the force. So again, that's exactly my point. You could stop right there and you would have gotten the right answer. Pressure is the force. That's right. The force is pressure. The force is weight. This is an energy detector. Okay. That's another one of the questions that should be on the test. Do you understand that this is an energy detector? Because every single interaction that takes place in the universe in which there is an exchange of energy is really just an exchange of weight. Mass times velocity. Mass and velocity. Now you can square it and half it and play a game that's somehow meaningful, but this scale doesn't see any of that crap. Okay, it doesn't measure that crap. It measures weight, pressure, just mass and velocity. That's what it measures. It's not going to be able to see, okay, your kinetic energy. Let's see. The force divided by area. Yes. So there's nothing, again, obviously, you're just changing how many atoms you're affecting with the force, and therefore you're affecting if it's fewer atoms, you're going to affect them with more velocity, because you're basically spreading your velocity based on the number of atoms you have to move. Okay, the sharper needle has less contact area than blunt ones. Yes, again, so there's no insight in what you're saying. That's exactly the argument being made. The wedge, okay, does a lot of pushing things sideways, where the flat thing has to push things down and then sideways. So obviously the blunt object has to do more work. It has to push atoms more over a longer period of time to get them out of the way. All right, hello Gary. Is wind a form of kinetic energy? Well, again, I'm arguing that there's no form of kinetic energy, but if you're talking in terms of kinetic active energy versus potential energy, so this should also be on the questionnaire. I mean, should it be called the speed of force? Okay, instead of the speed of light, because all the forces have the same speed. But I would also argue, instead of saying kinetic energy, when you mean active energy, so there's two kinds of energy: stored energy and free energy, or active. So if we use free, meaning the energy is free to go the speed of light, that's going to confuse people. But there's energy stored in systems. Okay, it's circular. It's going back and forth, or it's going around in a circle. It's trapped. So there's trapped energy. That would be called storage. And then there's energy that's moving in a direction, one direction. And that's liberated energy. And then you could say there's scattered energy, and that would be heat. But the energy itself is just made out of a vector. Okay, it's a vector, a mass velocity vector. And that's all the universe is made out of, is little mass velocity vectors. And when all the fish are swimming the same way, they can give you a bloody nose. Okay, but when all the fish are swimming in different directions, there isn't much. It doesn't mean much. So you're really just talking about energy in the sense of it's just mass and velocity. Everything can be understood as a quantity of motion, as Galileo, Descartes, and Newton understood it. And that's all there is. How much mass is there, and how fast is it going? So yes, wind is a form of momentum. It's physical objects, atoms moving, okay, being pushed, so yes, and it's caused by heat. So the wind is created by a thermal differential. But whatever. The fact is yes, I guess you could say that wind is just a consequence of heat. It's just air, isn't it? Well, saying it's just air doesn't say anything, right? I mean, air is obviously molecular molecules. And obviously planes fly because those molecules can be propellered. Okay, they can be given extra energy, and create a differential that means you will go in the forward direction. Fair enough. Okay, Newton doesn't say. Okay, yeah, no, I'm just saying. Be careful. Okay, because what people say. Newton didn't say F equals ma. So be clear. Newton didn't say that the energies are equal and opposite. He's basically saying there's an opposite force reaction. Okay, and I'm obviously arguing that that's not very articulate. That an object doesn't, friction isn't a force opposing something. Friction isn't some force opposing. Friction is just you losing your money. So it's just your money falling out of your pocket. Could be analogized to what friction is. Friction is just you losing rubber off your shoes or something. Friction is just you have energy. You're in contact with another surface. Now you're going to share your condition. And in fact, because this friction thing is bigger than you, you're going to end up looking like it. It's not going to end up looking like you. And so it's going to take any difference you have with it and eventually put you in the same condition it is in. Okay, so that's all that's being done. You lose energy through friction. There's no counter force that stops you from moving. There's no there's no counter force. There's no equal and opposite force. He says that forces are equal and opposite. So exactly what I'm just saying. There's no opposite force involved in contact. You contact something. If I do the Newton's cradle, okay, there's no equal and opposite reaction of any kind. I had this direction, and I gave this direction to this object. I had $10. I give it to something. That's one action. There isn't any two actions there. There's just one action. I gave it away. As soon as I gave it away, I became $10 weaker, and the other guy is $10 richer. But there's no counter force of any kind. There's no equal and opposite thing happening. And the rest of it is based on explosions. We know that explosions, generally speaking, are in all directions. So they always have a right and left component. They can't have one component. You can't explode something. You can't naturally expand something and then not have the expansion mean half the expansion is this way and half the expansion is that way. So if an atom expands, half the expansion is that way and half the expansion is that way. Can't undo that fact. So there's no opposite reaction force. There's the fact that the expansion had to go in both directions. Okay. Opposite. Equal forces over equal times, so at least you got the time part right, produce equal impulses, whatever the hell that even, it pushes with equal pushosity, okay, is equal changes in momentum, So I don't even, that's not a very, very good sentence. He says that forces are equal and opposite. What he says is that if you want to double the velocity, okay, the movement of an object, to use the word movement, you want to double the movement, double the force. So he clearly made a clear equal sign between movement, okay, matter staying the same, and force. Clearly, same thing. Force is momentum. And that's what you can glean out of his simple equation, where he just said force equals the momentum, change in your momentum, over a period of time. Now, the period of time could be the total net time, which means you just cross it all out, because it's a 1 unit of time. Or you can do it in, you want a rate, you want to know how much it is, 9.8 meters per second. Well, then you can have it as a rate. But if you don't want a rate and you just want to know the total, then you just do the net thing, create 1 unit of time, 15 seconds, cross them both out, and you basically have force equals the change in your momentum. So I'm just saying, it's mathematically, Newton said it, and he also said it in actual words. So he actually said you want to double the motion, double the force. That's the equivalence. You want to triple the motion, triple the force. That's what he said. That's what he wrote. So he's clearly making a clear equality, okay, between force and momentum. All right, but the work in each direction is different. I don't even know what to do with that. I have no idea what that could mean. So he said all of this. Newton doesn't say that the energies are equal and opposite. He says the force are equal and opposite, whatever that means. Equal forces over equal times produce equal impulses, duh. And it's equal changes in momentum. But the work in each direction is different. Sorry, it's just not true. So again, you want to say that work, I mean, again, I'm pointing out how it's just fallacious for you to think the work equation has anything to do with reality when you know it's a 9.8 meter per second force. So you can't apply it to anything gravitational because you already know that gravity's about time. It's not about fucking distance. So saying that work is force times distance is silly. Okay, on its face, silly. In any gravitationally controlled circumstance, because clearly it's a time-dependent force. It has to be, force times time. Joules don't hit the spaceship. Yes, they do. They're actually, that's a fact. Okay, it's that joules are watts. It's energy. Now, if you're going to pretend your energy isn't real, then you're just making my argument for me, aren't you? If you're saying it can't, I can throw these joule things at something. It has 2,000 joules, and I can throw it at something, and it doesn't move the thing. Then aren't you basically conceding it's not real energy? If the 8-pound ball going twice as fast doesn't make the pins go away with any more energy than the 16-pound ball, if the total pin movement isn't more, then aren't you basically saying your whole energy theory is absolutely fallacious and virtual and made up? It's not even real. It doesn't have anything to do with reality. It can't make a piece of matter move. If you can't make matter move with your energy, then how is it energy? I mean, it's just ridiculous. All right. So I'm just making my argument for me. So joules don't hit the spaceship. Force hits the spaceship. So, and what are you saying the force is? The momentum? So you're saying momentum hits the spaceship. So you're saying momentum is the real thing that's going to turn the spaceship. It's the real thing that has energy. The joules are clearly fallacious. They're just made up nonsense. They can't do any work. So what good are they? If they can't do work, what good are they? All right. I believe in conservation of momentum. I don't think throwing joules means anything. So I just don't know how that makes any sense. You're saying it doesn't mean anything, that I can convert that energy into wattage, okay, and that I could create 1,000 watts going one way, and I could have 1 watt of pressure the other way, heat, and that my spaceship isn't going to turn. I mean, I can just do it. Like I said, it's a direct conversion, okay? A joule is 1 watt. 1 watt is 1 joule. So I can just convert it into heat. And I can have the heat radiate out one side of the ship. And I can have the heat radiate out of the other side of the ship. And you're saying my ship's not going to turn. I'm saying obviously it's going to turn. So you're just playing games. You're just evading the fact that it doesn't make any frickin' sense to believe in 1/2 mv squared, because it doesn't work anywhere. It doesn't work in space. That's a big failure. If it doesn't work to turn a spaceship, then you know it probably doesn't have anything to do with basic mechanics of the universe. All right, it has the same effect because it has the same momentum. So again, you're just changing the goalposts all over the place. Yes, that's my argument. The physical truth is it will not change anything. Your extra wattage will not mean anything. Your extra joules, your extra crappy fake energy is just that fake energy because it can't move anything real. It can't do anything real. It'll never move a real atom. All right. Pressure is force per unit area. So we already heard that. So if you want to just keep reciting the same pointless mush, yeah, it's the surface area. So what? I mean, we all can figure out that I can, hit myself with a piece of paper, okay, a flat piece of paper, or I could take that piece of paper and roll it into a little spear, and I could, and it'll penetrate. That's the whole argument I'm making. That you can't drop round objects into clay and say you're doing a valid experiment to demonstrate how much energy it has, because it's a shaped object, and all I have to do is change the shape of the object and it'll penetrate completely differently. That's the bulk of the argument, moron. I mean, could you stay somewhere near the subject? I'm not making any contention that pressure doesn't change based on how pointy the surface is or the contact point. Of course the contact point matters. Fuck. Jesus. Alright, anyway. It seems like you have a lot of haters here. I'm glad you persevere. Yes, that's what I do. I endeavor to persevere. Like old Indians in great movies. Anyway, in spite of the BS and people's horseshit. Yes. Yeah, for real. Should have a store. Oh, please. I mean, you're going to say something this disgusting on my video? I should have merch? Fuck. God damn, I can't believe I see this written. Okay, and design some merch. Fuck you. As much as people hate you, I bet they would buy stuff. I'd burn the money. God, it's such a hideous concept, merch. It would never even occur to me to ever. I mean, if somebody auctioned off one of Einstein's hairs, I might bid a couple of bucks. What the hell? But merch, fuck. God, it's such a ridiculous world. If people want to help a cause, they should be able to figure out that why should I be paying the capitalist whores who printed the T-shirts an extraordinarily gigantic pile of the money? So of the $30, $3 goes to the guy I want the money to go to, and $27 goes to the stupid merch maker. What are you, in the merch business? Gross. It's just so gross. It amazes me that people will say things like this. I mean, why don't you just say, why don't you have a kitten for dinner? I mean, it's just, God, you don't know me very well, do you? Oh, fuck. Have a nice day. Just got a call. Whatever, blah, 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 and emoticon crap. Oh, so he didn't even hear me mocking him. Too bad. Did the apple, oh God, I don't need the image, really fall on Newton's head? It clearly, you could argue that the odds of an apple falling on your head are pretty thin, but clearly you could walk through an apple orchard, and I suppose it's possible, but I'm sure he saw apples fall, and they made a thud, and, so I'm sure it didn't actually have to hit him in the head. But I think there's some evidence that Newton said it didn't hit him in the head. Or is that just a myth? He had a conversation with somebody, that was referenced by the somebody in the conversation, at some health spa or something. I don't know. Where he related these stories. But you know how people are when they're getting old and they start telling stories about the big fish story. You know what I mean? I mean, it gets, we're all a little bit capable of gilding our story lilies, so who knows? Who cares? I mean, I just don't care. I mean, could we actually talk the actual physics? Does it always have to have all this extra peripheral babble in it? This kind of work is not easy. You need to have a full knowledge of the subjects. No, you don't. Frankly, what do you mean by full knowledge anyway? That doesn't even mean anything as a concept. Obviously, you have to have the reference material. I mean, you have to, if you're going to play hockey, you have to have a stick and a puck and ice, you know. So yeah, you have to have a certain amount of foundational information to be able to make some relevant comment on the subject. Let's see. I don't blame your once-in-a-while burst due to losing patience. I don't care whether anybody... I obviously don't care whether anybody minds it or not. I'm just saying I'm entitled to some kind of respect. And if people are going to be patronizing, and then they're going to be redundant, and they're going to basically say, personally tutor me. Okay, I made thousands of videos. They're basically saying, I won't bother watching 4 of them. Okay, I'll watch 1.5. And I'm going to say, get out of the conversation, because, yeah, 1.5 videos isn't going to be enough. So if that's all you're willing to watch, fuck off. Because I'm really not going to personally tutor you. You know. People really need to be listening before speaking. Well, I mean, the fact is, you have to actually know what the person's argument is. I mean, if I was researching somebody else and they're making a claim, then I watch every video I can on the subject, like on Veritasium on photons, Veritasium on electricity. I watched every one of those videos to try to find out why he's thinking what he's thinking. You know, I mean, you try to find out what it is that's got him on this kick. And, you know, I don't expect that you can do it any other way. You really do have to get as much information as possible about what the person's saying and why they're saying it. And these people don't want to do any of that. Work is defined as force times distance. Right, I already said those exact words, didn't I? Yes, I did. And it's a silly definition. I'm saying to you it's a silly definition, that if I hold up a 10-pound weight, I'm doing lots and lots and lots of work against gravity. It's not moving, but I'm doing lots and lots of work. It's just a fact. Because it is subtly moving is the fact. But regardless, your physics says motion, okay, in one direction, accomplishing a distance is work. But if I just go back and forth, I don't do any work because I don't travel any substantial different distance. And you're basically saying that any distance I do that way will undo any distance I do that way, so I'm going 0 amount of work. I mean, it's a silly definition. Frankly, it's silly. Especially in the context of 9.8 meters per second. I mean, if it was 9.8 meters per foot, well, then work would be relevant. But obviously these forces are not in increments of distance. They're in increments of time. It's about how long you apply a pressure. It's not about the pressure itself, and it's not, it doesn't have anything to do with how slippery the surface is you pushed it on. I mean, how much distance you got. It doesn't have anything to do with how much real work you did. Are you arguing that the definition is wrong? I mean, I've only said it 4,000 times. It's a definition. It's a retarded definition. Again, I'm holding a 50-pound barbell and it's not moving. You're saying I'm not doing any work. Ridiculous state. Okay. I mean, I can't make it any clearer than that. It's a ridiculous definition of work. Work isn't about how far you go. And gravity proves it. I mean, I could say that over and over again. Twice the time, falling time, twice the weight when you measure its weight. So I go 4 times the height. All I get is twice the weight. Twice. So I drop it from 1 unit of height, I get a weight. I drop it 4 times higher, I only double the weight. I mean, can't you get it? Twice the weight, twice the velocity, twice the time. And you keep saying 4, 4, 4, 4. Yeah, the distance isn't giving you the truth, okay? The distance isn't the right answer. The time is the right answer. The velocity is the right answer. The weight is the right answer. So, of course, I'm saying it's a crappy definition. It's MGT, not MGH. Okay, if a table holds up the same weight, so again, this is silly because tables are not working, okay, in this traditional sense. There's obviously pressure and it's being conveyed to the earth, and the earth pushes back and it has to be conveyed to the table. All right, but we clearly know the table isn't elastic, so it's not going to be, how to say it, it's not going to be yielding and then pushing back and doing its own work. Okay. Is the table doing the same amount of work as when you hold the weight? So obviously it's a different amount of work, because to hold the weight, you're not doing it through your skeleton or something. So yes, if I put the weight on top of your head, you could say, yes, it's a lot less work. I mean, that's why those African women have all that crap going right through their spine and through their, as direct path as possible, is to force it to go through their skeleton rather than going through their musculature. Okay, so obviously anything we do with our musculature, it's a bunch of leverage and a bunch of action all the time. So we're doing a ton of work because we're constantly losing to gravity, and then we overcome the gravity, then we lose to gravity, and then we overcome the gravity. So we're constantly adding energy in the form of friction. Okay, in the sense of we're having to create contact against the gravitational force. All right, I would say it is. Okay, let's see. Let's see what it says. If the table holds up the same weight, is the table doing the same amount of work as when you hold up the weight? Okay, so he's saying, I would say it is. Well, I'm saying it's obvious tables aren't sweating. So they're not providing any extra energy. So they've reduced the motion to exactly what the earth is doing. So the earth does the work of pushing you back. And that work requires something else on the earth to be pushed in. So the pressure has to be maintained. You're pushing into the earth, it has to push you back up. It has to, in a sense, use some pressure to push you back up. But you made more pressure by pushing in, is the key fact, right? So you increase the pressure, the earth will equalize the pressure and push it back up. So you're jiggling in gravity constantly. And all you're saying is I'm going to put a rigid object between me and the jiggling earth. So the earth is pushing you back, and you're just creating a stiff object in between, an unelastic object. The difference is we're very elastic. So we're going to end up having to do a lot of work because we're going to jiggling at a different rate than the earth is. All right, I would say it is. Both are doing zero work on the weight. Okay, so this is just baby talk, in the sense of it's kind of, again, it's so obvious that you are doing work on the weight. Gravity wins, you push back. Gravity wins, you push back. Your body is expending energy, and you're staying in the gravity. The gravity is constantly pushing. You're constantly having to push back against it to keep the muscle in place, but that's an inefficiency. It doesn't matter whether it's an inefficiency. The argument is yes, of course it's an inefficiency. You're wobbling the weight. You're jiggling it more than it needs to be jiggled. Gravity is going to cause the earth to jiggle a certain amount. You're adding a whole bunch of extra jiggling, okay, because you can't maintain the weight in one position. The energy doesn't go to the weight. It's lost as heat. All energy is lost as heat, you could argue. It's all terminated somewhere in a event that rescatters it. Okay, so the fact that, yes, it's really hard to capture energy in an environment where you can maintain its function for millions of years. So inside of atoms it works, but just about everywhere else it's pretty hard to create a bottle that doesn't leak, and some things leak a lot. So that's not a statement that defends anything. It doesn't explain anything. You're saying that work is force times distance. Okay, I'm saying clearly Galileo, Newton, and Descartes already knew 500 years ago, okay, that 4 times the height is only twice the velocity, twice the weight, okay, and it's only twice the time. And Newton certainly discovered it's a time-dependent force. It's happening in units of time. So it depends on how long you're in gravity. Again, I've done this one so many times. I have a gravitational body. There's a certain expectation of a certain amount of gravity in this area. I'm going to travel this distance. Okay, the faster I travel the distance, the less I'm going to get bent. Fact. So the distance isn't deciding how much force is going to bend me. It's the amount of time I spend in the distance. It's a completely time-dependent force. It's all about how much time are you in the force. That decides how much work you have to do. Period. I mean, that is so simple and obvious. You're falling. The first quarter of the fall, all right, the first quarter of the fall will take as long as the next 3 units of fall time, okay? And you're going to go this 3 times the distance, but you're only gaining 9.8. You went 3 times the distance as you're falling, but you're only getting 9.8 because it's only 1 unit of time. 3 times the distance, 1 unit of time. So you have 1 unit of time for the first quarter, 1 unit of time for the next 3 quarters. That's how gravity works. It's only 2 units of force. Let's see. Let's see. That's an inefficiency. The energy doesn't go to the weight it is lost to heat. Okay, you already did that. What happens to an object if it goes faster than the speed of light? Well, I'm just saying, how do you push something? If the pushers only can run the speed of light, how do they make something go faster than the speed of light? I mean, if I'm going to push another car, my car can only go 30 miles an hour. How do I push the other car 40 miles an hour? Can't do it. Okay, so it's silly. As a statement. Now, let's say you could push an electron twice the speed of light. It would just mean it's got twice as much energy. I mean, it's still going to just do transfers with the rest of the things it hits in the universe. So let's pretend that the force isn't involved. We just have an electron going very fast, and it's going to hit an atom, and it's going to spread its energy over numerous other electrons and protons. Well, then that force would just end up being divided back into something less than the speed of light. So it wouldn't be like some miraculous event, like you go 1 mile an hour faster than 3 million miles an hour, and all of a sudden, the world universe changes. No, you're not going to change anything. All right. If this universe has the smallest unit of length, I don't know. You people just can't stay on the subject, and you just can't stay in anything real. You have to just play little games about how the universe has a length. Okay, anyway. Yeah, you could say you could pixelate anything. I could take anything and I could make it into smaller and smaller things. And even the atoms I can subdivide, and theoretically you could subdivide an electron. But the fact is that the electron doesn't function as subdivisions. It only functions as a collective. So there's a point where it's totally useless because none of those other bits have any function. They don't do anything. So electrons it's checkerboard. Okay, and once you break down the red and black squares, you're already as elemental as you can get. It doesn't matter what the paper atoms are doing. The paper atoms aren't going to change the red color to a black color. So it doesn't matter. There's a point when you're pixelating the universe and you're not going to gain any information because none of those elements of that smaller and smaller detail have any effect on the checkerboard. What happens when an object, okay, we already did that, smallest unit of length, then their theory is wrong because it assumes otherwise and relies on it. Well, obviously they don't believe in three-dimensional space, so how could a unit of length mean anything to them? So yes, I mean, that's a whole nother problem, though. Isn't that a whole different subject, Einstein's relativity? I'm pointing out here in these videos how they can't get a photon right, and they can't get a basic element of physics right, which is energy. They can't do it. And it's not that, like I said, if they would just start where Galileo, Descartes, and Newton left off, they'd be okay. But they ruined that by jumping on the Leibniz, cult religion bandwagon. The living force. I mean, it's just so unscientific on its face. The guy introduced something that on its face was insanely unscientific. The living force. I mean, crap. their theory of conservation of energy. I guess you're saying, but I just don't know where you're going. Okay, so, relating relativity to this conversation, I think, is not going to be very productive. Famous Gandhi quote will apply to draft size experience in this planet. First they ignore you, then they laugh at you, and then they fight you, and then you win, or they kill you. I mean, a lot of people died, in Gandhi's war. He killed a lot of people, so he was pretty protected, I don't think Gandhi's much of a human being, frankly. I mean, first he had kids, which is an insanely stupid thing to do in a poor country, and then he didn't educate them, which is just like so obnoxious. And he basically wanted the people of India to spend their lives knitting booties for, rich Americans. And why would that be your ambition for your country? It's a pretty shitty ambition. Let's all just be blacksmiths and, fishermen and, let's not be scientists, even though he was well educated. And he just, to stay ignorant, that's just ugly. I can make the harshness of the world go away by making myself blind to it. Wow. That is just so cowardly. All right. Was splitting the atom humanity's biggest mistake? Well, frankly, I don't know what you mean. I mean, people died in plane crashes. That means we shouldn't have had planes? I mean, you don't think that eventually we would master... Look at all the nuclear power plants, the small ones in, aircraft carriers and all, submarines and all that stuff. They've had no major disaster with all of those uses of nuclear power. And the fact that you could make bigger and bigger bombs was just an inevitability, wasn't it? Okay, so to me, it's in some way our salvation. Is the fact that maybe someday we'll have the technology to split the Earth in two and crash it into the sun, and do the universe a big, huge favor. Because frankly, there's nothing happening on this planet, that isn't just nasty. I thought it was. First they laugh at you, then they make arguments against you, then you block them, then you win. So, whatever. I mean, if you think I have blocked somebody unfairly, you're entitled to that opinion. But I'm also entitled to what I consider minimum amounts of respect. And you're not respecting somebody when you're forcing them to personally tutor you, okay, in a chat. Okay, that's bullshit. You should have to pay for that, okay? You want me to explain the same shit over and over again? Well, then you should pay me to do that for you, okay? So, yes, let's say $10 an hour, okay? I'll be really fair. But you're going to have to pay me if you're not going to watch my videos. Oh, whatever. AI. So now you're going to call a drone AI. Okay, whatever. It's just so pathetic. A calculator will go to Mars. Yes, wow, a calculator is going to go to Mars. Yeah, it's be so exciting. We sent a calculator. We've already done that. Newsflash. Ugh, fuck. It's one of those Darwin things, okay? You want to see how you go backwards and devolve? Is you find the people who want to go to Mars, okay? And you say, there it is. Okay, that's genetic devolution. Because what the fuck is wrong with you, you lunatic? I want to, when people want to do something ridiculously stupid, you have to ask the question, why the fuck, how could they be that retarded? What are you going to do at Mars? What the hell? You're going to sit in your little box smelling your own shit? And what? Watching Bugs Bunny cartoons? It's just hilarious. Oh, the best form of existence. Oh, I'm not going to do these other subjects, so that's another reason to block people. I mean, come on. This is just silly little baby talk. AIs aren't conscious. Okay, they don't have orgasms. They don't have impulses. They don't have warm feelings or creepy feelings. What does it have to do with existing in any meaningful way? Okay, they don't exist. They're bricks. Rusting. It's a rusty piece of steel. Okay, yes, it's active, it's doing something, but it doesn't mean anything. God damn. I mean, people are just so delusional. No AI has a feeling. They're in no real way alive. They're just duplicating a mechanical logic function. A mundane process, Combine ingredients and bake a cake. It's just nothing. Nothing brilliant about it. Nothing all interesting. But this is what captures the imagination of the fucktards on Earth. Ugh. Alright, looks like things is winding down, so we'll do the 2-minute warning thing. And we have to wait all the way till next week. Oh. Seems like an awful long time for him to just admit the evidence sucks, but see, that's all I'm really, that's the fair cop thing here, is that all these people defending the conventional crap should be able to admit, God damn, I really wish they secured all of this crap they say with a nice volume of nice credible evidence. They really should have done one of these fuel experiments and proven that it takes 4 times the fuel to go twice as fast. They really should have done that. Alrighty then, I guess you have given up. Yeah, so I guess I win. Oh, funny. So let's see, they make an argument against you, then you wait for them to make a better argument because that last one really sucked, and then you win because they don't make a better argument. Yeah. Okay. Well, at least didn't have to block anybody, so that's progress, I suppose. So, till the next time, and such and so forth, and whatty not. Blah, 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 blah. Well, might as well go another 40 seconds, and make it a round 1 hour and 30-minute video, and such. Boy, time really does go slow when you're watching it. When you're watching the clock tick, it's just... But otherwise, it just zooms right out of your fingers. I have a lot to do today, and I won't have enough time to do it. So anyway, and I'll make excuses as I do that. Alright, so now we're done. So till the next time, and such, and so forth, and whatnot.